Hello everyone. Today we are presenting a video on the topic vehicle steering system for our course automotive systems. Steering is the term applied to the collection of components, linkages, etc., which will allow a vehicle to follow the desired course. An automobile is steered with the help of steering gears and linkages, which transfer the motion of the hand-operated steering wheel to the pivoted front wheel hubs via steering column. The other parts that are used for steering a vehicle are steering wheel pads, steering shafts, steering boxes, steering arms, and steering stabilizers. These parts are made of durable materials like stainless steel, iron, aluminium, copper, magnesium, titanium, platinum, rubber, and plastics. Next, we come to the functions of steering system. It helps in swinging the wheels to the left or right. Then, it converts the rotary movement of the steering wheel into an angular turn of the front wheels. Next, it multiplies the effort of the driver by leverage in order to make it fairly easy to turn the wheels. And at last, it absorbs a major part of the road shocks, thereby preventing them to get transmitted to the hands of the driver.
Now let us focus on the components and the working of the steering system. So the first part is the steering wheel. It is made up of steel and welded on the hub with the help of two other spokes. In India, the position of steering wheel is fixed. In so many other countries, the steering wheel can be tilted or located in a position which suits the driver. So the next part is the steering column. It is a hollow steel pipe in which the steering shaft is housed. So next part is steering shaft. It is made up of steel and it is one of its end is fixed in the steering wheel with the help of the spines or key. The other end of steering shaft is connected to the steering gearbox with the help of bearings. So next part is steering gearbox. It converts rotary motion of wheel into to and fro motion of drop arm. Because of this drag link which is connected to the drop arm it can be pushed or pulled. Next part is the drop arm. It is also made up of steel. So now let us focus about the working of the steering mechanism. Steering wheels. The steering wheel rotates the steering column. Steering gearbox is fitted at one end of the steering column due to rotation of the steering wheel. Cross shaft in the gearbox oscillates. Cross shaft is also connected to drop the arm. Drop arm is linked by the means of a drag link to steering arm. Steering arm is connected to front steering wheels with the help of a tie rods. When the steering wheel operates, the knuckle moves to and fro. The end of the tie rod and knuckle are connected to each other. Both the ends of drag links are connected to tie rods. A ball and socket joint gives the required movement to the joints between the rods, the drag links and the drop arms. When the vehicle moves, the drop arm develops vibration. Shock springs are used in ball and socket system to absorb these vibrations.
Next we come to steering geometry. The term steering geometry refers to the angular relationship between suspension and steering parts, front wheels and road surface. Because alignment deals with the angles and affects steering, the method of describing alignment measurements is called steering geometry. There are five kinds of steering geometry angles: camber, caster, kingpin inclination, toe in and toe out on turns. First, camber. Camber angle is the angle between the vertical line and center line of the tire when viewed from the front of the vehicle. Camber angle is positive when this is outward. This happens when wheels are further apart at top than at bottom. On the contrary, camber angle is negative when angle is inward. This happens when wheels are further apart at bottom than at top. The camber should not be more than 2 degrees because this causes uneven or more tire wear on one side than on the other side. Now we come to caster. Caster angle is tilt of the kingpin center line towards front of the back and vehicle vertical line. It is the angle between the vertical line and kingpin center line in the wheel plane when looked from side. Next we come to kingpin inclination. It is the angle between kingpin center line and vertical line when seen from the front of the vehicle. It is also called steering axle inclination. Kingpin inclination and caster angle are used to improve directional stability in cars. This is also used to reduce steering effort when steering a stationary car. It reduces tire wear. This inclination varies from 4 to 8 degrees in modern cars. Next, the final one is toe in and toe out. In automotive engineering, toe is also known as tracking. This can be contrasted with steer, which is the anti-symmetric angle. Both wheels point to the left or right in parallel. Positive toe or toe in is the front of wheel pointing towards the center line of the vehicle. Negative toe or toe out is the front of the wheel pointing away from the center line of the vehicle.
Now let us talk about power steering. It has been used in modern vehicles to steer the wheels under a lot of pressures. So power steering has two types of devices for steering effort. One type is a hydraulic device utilizing engine power. The other type utilizes an electric motor. For the former, the engine is used to drive a pump. For the latter, an independent electric motor in the front luggage compartment is used as the pump. Both develop fluid pressure, and this pressure acts on a piston within the power cylinder so that the pinion assists the rack upward. The amount of this assistance depends on the extent of pressure acting on the piston. Therefore, if more steering force is required, the pressure must be raised. The variation in the fluid pressure is accomplished by a control valve which is linked to the steering main shaft.